Yes, hello friends, welcome to the session. Continuation of the classroom workbook based on the topics of buck regulator, boost regulator, that is step up choker, and buck boost regulator. Okay, continue with this classroom workbook based on this topic, chapter 7, DC to DC converter. In the last session, I given up to question number 22nd. 22 is completed. Okay, then we go through with all of you take the workbook. See the question number 23. Question number 23. Okay, all of you read the question. This question number 23. Read the question. A chopper circuit shown in figure operated at a duty cycle of 0.5. The converter switching frequency is dash. This is given circuit. Is 40 volts. Then this is 100 microhenry. It is given 100 microhenry. The switch is given is a MOSFET is a switch is given. Okay, this is diode and capacitor. The resistive load of 50 ohm. Is 100 volts. This is how much it is given. 100 volts. If the duty cycle is 0.5, then you find switching frequency. Here data is available to check the continuous or discontinuous mode. It is not mentioned in the problem operated in continuous mode. But first you check the condition, is it a discontinuous or continuous? If you assume that it is a continuous mode, you calculate what is V0, what is regulator, boost regulator. This is V0 equal to S, VDC by 1 minus D. VDC is how much? 40 by 1 minus 0.5 is how much you get? 80 volts. Then this is 100 volts, this is 80 volts. This you calculate under continuous mode. That's why V0 under continuous mode, how much we are getting? 80 volts. This 80 volts is less than 100 volts. But actually in this circuit, how much we are getting? 100 volts we are getting. This is in this circuit, output voltage is given 100 volts. But if you solve this circuit in continuous mode, we are getting 80 volts. That's why this circuit is not under continuous mode. If you want to get the 100 volts means the circuit must be operated in discontinuous mode. That's why it is under discontinuous mode. Now, you want to calculate switching frequency. First, you see in the discontinuous mode, what is V0 equal to VDC by beta minus D, because it is a boost converter. VDC by beta minus T. What is the output voltage? 100. What is the VDC? 40. Beta minus, what is D? 0.5. Then B minus 0.5 equal to how much? It is 40 by 100, that is 0.4. Okay. Then this is 100 volts, it is given, that is beta VDC. Beta VDC by beta minus T. This is the formula. Then how much? Beta by beta minus 0.5 equal to 100 by 40. Is how much you get? 5 by 2. Then 2 beta is equal to 5 beta minus 2.5. Then what is 3 beta equal to 2.5? Then what is beta equal to 5 by 6? This is the beta. Calculate beta in this case, then we get 5 by 6 because it's a discontinuous. Then you want to calculate what is the switching frequency. Okay. Then if you want to calculate switching frequency, means switching frequency calculated by using during on time or off time relation. Okay. First, I want to define what is IL average. What is IL average? Is it discontinuous mode now? Discontinuous mode. A discontinuous mode, what is IL average? This is IL waveform, you can draw. Then we get at beta t, current is 0 before completing one time period. This is what this height? This is delta IL because IL minima equal to 0. Then half into delta IL into beta t by t. Then what is IL average equal to? IL average equal to half into delta IL into beta. This is IL average. Yes. Can you tell me what is the power delivered to the load? You know this 50 ohm resistor, this is 100 volts. This how much you get? 2 ampere. The power delivered is, shall we calculate like this? So remember this is one equation. What is VDC into IL average? VDC into IL average equal to the power delivered to the load. VDC into IL average equal to 2 into 50. This is how much? This is 100 volts. This. Then 2 into 100. 200 watts. Power delivered. Now from this, what is IL average equal to? 200 by 40. How much you get? 5 ampere. How to write power delivered? The output power. Output power is nothing but this one. We know that input power equal to output power. How to write input power? VDC into IL average. You can equate input power equal to output power. What is output power? This one. What is the input power? VDC into IL average. Now from this we calculated IL. To substitute IL average here, then this is IL average. This substitute IL average here, then what you get? 5 equal to half into delta IL into, what is the beta we calculated? 5 by 6. Then from this, what is delta IL? We can get delta IL equal to 12 ampere. But you don't want delta IL, you want switching frequency. For that, during on state, during T on, VL equal to this formula. If the switch is on, apply the KVL for this loop. VL plus VL is equal to VD. That is VL equal to VD. Switch is on means diode is off. VL equal to VD. What is VL? You write L into delta I by dt. VL is written as L into di by dt. This is equal to VDC is how much? 40. Shall you write like this? L into delta L by dt is nothing but a during T on time. T on is nothing but a dt. This is 40. dt during which time? This is on time. T on is nothing but a dt. Then L is how much it is given? 100 microhenry. 100 in 10 to the power of minus 6. What is delta L? You tell me. You calculated 12 ampere. D, duty cycle is how much? It is given, duty cycle is given as how much? 0.5 into 40 is equal to T. Okay, this how much you get? This is simplify this, then how much you get? T equal to 60 microseconds. Is correct? This we get 25 times 60 microseconds. But you want switching frequency now? Switching frequency equal to 1 by T, 1 by 60 into 10 power minus 6, then F equal to S, 1 by 60 megahertz. This is the frequency, switching frequency. Clear? Concept. Concept very simple. I want to calculate the switching frequency. That's why I will use this data. Then to calculate delta L, I will use this data. If you want delta IL means IL average. That's why I calculated input power equal to output power. From that I calculated IL average. I substituted here. Then from this delta IL I am getting. That delta IL I am substituting here. Then we are getting the switching frequency. Is clear? Yeah, that you can. Have you read the question? A buck converter shown in below figure operated with a switching frequency of 20 kHz and duty cycle of 0.5. Then calculate average output voltage. Yes. What it is given? This is the buck converter. Inductance is 500 microhenry. This is capacitance. Resistance is 50 ohms. Okay. The switch VDC is 30 volts. This diode. In this circuit, what the switching frequency is given? 20 kHz and duty cycle is 0.5. Then you calculate what the average output. Here you calculate average output voltage. Here it is not mentioned that it is a ripple free. There is no any ripples and it is a continuous mode. A large inductor like that, it is not mentioned. Then you have the doubt here. You want to operate is a continuous mode or discontinuous mode. One method of checking the continuous or discontinuous mode I told already. If any output voltage is given based on the given duty cycle, you calculate average output voltage in continuous mode. Then you compare those two. If it is less, then it is a discontinuous mode. If it is greater than whatever the voltage is given, then it is a continuous mode. But here data is first to check the data is available to check the continuous mode or discontinuous mode. Otherwise, you take the formulas in continuous. Yes. Inductance is given. Duty cycle is given. Frequency is also given. That's why there is a data available to check the continuous or discontinuous mode. Then how we can check the continuous or discontinuous mode means two conditions I told. One is if the average output voltage in the continuous mode is less than the given voltage, then it is a discontinuous mode. And the another way to check the continuous or discontinuous mode is by calculating the critical inductance. That I told already. First you calculate what is the critical inductance. It is a buck converter now. R into 1 minus D by 2F. Then what is the resistance? 50 ohms. 1 minus duty cycle is 0.5 by 2 into frequency is how much? 20 kilohertz. Frequency is 20 kilohertz. Then what is the critical inductance? LC equal to 50 into 0.5, 2 into 20 into 10 cube. You simplify this, we can get 625 millihenry. But given inductance is how much? 500 microhenry. That is, therefore, L given is how much? 500 microhenry. But LC how much we getting? 625 millihenry. Therefore, LC, L given less than LC. L given less than LC. Hence, it is discontinuous mode. It is discontinuous mode. Okay, quick, no doubt. Now we want to calculate average output voltage in the discontinuous mode. Hold on, quick. Yes. Tell. Then what is the average output voltage in the discontinuous mode? V0 equal to dVdC by beta. V0 equal to dVdC by beta. Then you don't know about beta. Then how to calculate beta? Yes. Even if you want to calculate from average load current, means you don't have any average output voltage. Once you know this current here, then you can equate input power equal to output power. Then from that data we can calculate. That is one way to calculate beta. But voltage, output voltage is not given. Then how to calculate beta value? Listen please. Go for this data during T on. During T on. Tell me, L into during T on means switch is on. Apply KVL for this loop. Then what we can get? VL plus this equations you know. V0 equal to VDC. Then what is VL equal to? VDC minus V0. Okay. VL equal to VDC minus V0. How to write VL? L into delta I by dt. Delta IL by dt. Okay. L equal delta IL by dt. Now from this, you write, I am taking V0 is common, or shall you write in terms of this equation? You write in terms of VDC. VDC how you can write from this one? Beta V0 by VD. Beta by V0 by D minus V. Then L into delta IL by dt equal to, take V0 is common, beta by D minus 1 into V0. Okay. Shall we write V0 is I0 into R? V0 is written as I0 into R. L into delta IL by dt equal to beta by D minus 1 into I0 into R. Okay. I0 into R. Okay. Now from this, you tell me, what is I0 is, in the case of buck converter, I0 is how much? IL. L into delta IL by dt equal to beta by D minus 1 into, what is I0 is IL. IL into R. That this is one equation. But how to define IL average? IL average is nothing but IL. How to write? Same, it is a discontinuous mode now. How to write IL average? Half into delta IL into beta T by T. This one. Under discontinuous mode, what is the wave shape we are getting? Under discontinuous mode, this IL waveform. IL minima equal to 0. This is beta T. Okay. This is delta IL. This delta IL is IL max. Okay. Then again this is T. Again it will be started like this. Okay. Now I am calculating this area under this curve. Area under this curve. Half into delta IL into beta T by T. Now from this, what is IL equal to? Then TT cancel, half into delta IL into beta. Can I replace this IL by half into delta IL into beta? Then what we get? Then we know that L into delta IL by dt is equal to beta by d minus 1 into, I'm equating IL by half into delta IL into beta. Half into delta IL into beta. Delta IL is cancelled. Then what we get? This is already R is there na, into R. Shall you write like this? L by dt is equal to beta minus d by d into half into this, how much we get? Beta R. Yes. Then this d is also cancelled. Then what we get? Beta into beta minus d equal to then 2L by RT. 2L beta into beta minus d equal to 2L by RT. Okay. Then shall you write this equation like this? Beta square minus d beta is equal to 2L by RT. Then you bring this side. Then what we get? Beta square minus d beta minus 2L by RT equal to 0. One quadratic equation we can get. Then from this, how to calculate beta? Beta equal to minus b plus r minus d plus r minus square root of b square d square minus 4ac. 4ac, that is 8L by RT. 8L by RT. Shall you write like this? By 2a. Then what is beta equal to d plus r minus square root of. D's duty cycle is how much? It is given 0.5 square. This is 0.5 plus 8 into L is how much? It is given 500 microhenry. 500 into 10 power minus 6 by RT. R into R is how much? It is given 50. What the frequency is given? T is 1 by F. 1 by 20 kilohertz. 1 by 20 into 10 cube by 2. By simplifying this one, we get beta is nearly equal to 0.93. We can get both positive and negative values. Then you take the positive value. Then we can get beta equal to 0.93. That you do that by your own. Yes, I'm calculating quadratic equation. By solving this quadratic equation, we can get both positive and negative values. Then you take the positive value. Then how much beta we can get? 0.93. Clear? Once you know the beta is 0.93, then how to calculate average output voltage? Then the average output voltage is equal to D into VDC by beta. This V naught equal to duty cycle is 0.5. What is VDC? 30 volts. Beta is how much we are getting? 0.93. Then by simplifying this one, we can get average output voltage equal to 16.128 volts. This is the answer. V naught equal to 16.128 volts. Clear? Understand what I taken here? I written this total equation in terms of beta. Then in order to cancel this one, I calculated IL average. From this IL average, from this I calculated IL. That IL, I replaced IL by this one. Then delta IL cancel. Then I am getting total equation in terms of beta. From that I calculated beta. You substitute the beta in that equation. Then we can get average output voltage 16.128. Clear? concentrate. Quick, no doubt. See the question number 25. You read the question. Yes. A DC to DC converter operated at a duty cycle of 0.4. Load resistance is 150 ohms. A DC to DC converter operated at a duty cycle of 0.4. Load resistance is 150 ohms. Internal resistance of inductor is 1 ohm. The internal resistance of inductor is 1 ohm. Then determine the voltage gain in steady state. Determine the voltage gain in steady state for buck regulator, and boost regulator, and buck boost regulator, and assuming that load is consist of ripple free DC current. Assuming that load is consist of ripple free DC current, because it is a continuous mode. It is mentioned that continuous mode. But you want to calculate what is the voltage gain in buck regulator and boost regulator and buck boost regulator for this case. Here the concept you see, here the resistance of inductor is also given. If the resistance of inductor is also given, how to analyze? This is a practical case. In the practical conditions, how to analyze the circuit already given. But I given only for boost regulator and buck boost regulator. But here it is asked for buck regulator also. Okay. First you will see for buck regulator directly I am not given the formula. I don't want to apply directly. But boost regulator, buck regulator, I already given the derivation. That's why directly I will apply that formula. But for buck regulator, you see. First one is for buck regulator. If you consider the buck regulator means, okay, if you consider the buck regulator, then this is a switch and this is diode. The supply voltage is VDC. Then resistance of inductor is also given. That the internal resistance of inductor is small r. This is L. And this is capacitor, and that this is the load. Load is resistive. Okay. If we consider the internal resistance of inductor also, let this current is IL. And this is the switch or choker. This is 150 ohms. This VL. This is V0. This capacitor. Okay. Now, if the switch is on, If the switch is on means, what is the KVL you tell me? KVL is IL into R plus VL plus V0 equal to VDC. Then from this, what is VL equal to VDC minus V0 into minus IL into R. Extra IL into R we can get. Then what is KCL you tell me? KCL is, let this is IL current and this is IC current. This is I0 current. Then what you can write? IL equal to IC plus I0. Then what is IC equal to IL minus I0. If the switch off, if the switch is off state, then what is KVL you write? IL into R plus VL is equal to minus V0. Then what is VL equal to minus V0 minus IL into R. What is KCL? I'm not drawing all the equivalent circuits, all this that you already explained in the operation in continuous mode. But extra we are getting IL into R transport. Then what is IL equal to IC plus I0. Then what is IC equal to IL minus I0. This is KCL. Then go for volt second balance, ampere second balance. According to volt second balance, if you take volt second balance, What is the volt second balance? VL on into T on plus VL off into T off. That is VL on into T on plus VL off into T off. VL off into T off is equal to 0. What is VL on? VDC minus V0, VDC minus V0 minus IL into R into T on. What is VL off? That is minus VL off is how much? Minus V0 plus minus V0 minus ILR into TR is equal to 0. Shall you write like this? VDC into T on minus V0 minus ILR is common. T on plus T off is equal to 0. Then VDC into T on. T on is written as DT. DT minus V0 minus ILR into T is equal to 0. Shall you write like this? dVdC minus V0 minus ILR is equal to 0. But I want to write IL into R. This is IL into R. Resistance na IL into R. IL into R equal to 0. Yes. I want to write IL. I want to write IL equation. Okay. You want to write IL equation means how to write? It is according to ampere second balance you calculate. According to ampere second balance means it is a which regulator? In buck regulator. In buck regulator. This is calculated according to ampere second balance that you already know. In buck regulator, what is IL equal to I0? Shall you write like this? dVdC minus V0 I0 into R. I0 into R. But I0 is written as V0 by R na? Then how write? dVdC minus V0 minus V0 by R into small r is equal to 0. Then what is dVdC equal? Take V0 is common. 1 plus small r by capital R. Then what is V0 equal to dVdC by 1 plus small r by capital R. Now, this is the output voltage with respect to internal resistance of inductor in the case of buck regulator. Then what it is asked? You want to calculate voltage gain in buck regulator. Then what is the voltage gain? Then voltage gain equal to voltage gain is output voltage by input voltage V0 by VDC. Then what we get? D by 1 plus small r by capital R. Then what we get? D is duty cycle is how much it is given? 0.4. 1 plus small r is how much? 1 ohm. What is the capital R? 150 ohm. By simplifying this, we can get 0.397 that you do. This is the first question. For buck regulator, because in the discussion of concept, I not given the derivation, but here I am giving the derivation also. V0 equal dVdC by 1 plus small r by capital R. Then from that you calculate what is the voltage gain. Voltage gain we are getting 0.397. This formula directly also you remember. V0 equal dVdC by 1 plus small r by capital R. Okay. Then what B? You want to calculate voltage gain in boost regulator. Can you tell me what is the voltage gain in boost regulator? What is the voltage gain in boost regulator? In boost regulator, what is the formula I given already? I am not giving derivation. In boost regulator, what is V0 by VDC? You write V0 by VDC. We can write 1 minus D by small r by capital R plus 1 minus D whole square. This formula you. V0 equal to 1 minus D into VDC by small r by capital R plus 1 minus D whole square. Then all the values you know. All the values you know. Yes. Concentrate. By knowing all the values, then what is V0 by VDC equal to 1 minus 0.5 by small r is 1 by 150 plus 1 minus 0.5 whole square. This is simplify, you can get 1.636. 1.66. Then what about in buck boost regulator? In buck boost regulator. In buck boost regulator. In buck boost regulator, what the formula? V naught by VDC equal to 1, that is D into 1 minus D by small r by capital R plus 1 minus D whole square is the in buck boost regulator. Then you substitute all the values. What you get? You tell me. Substitute all the values. Then what is V naught by VDC equal to? D is 0.5. 0.5 into 1 minus 0.5 by small r is 1 ohms, 150 plus 1 minus 0.5 whole square. Then you calculate this, how much we can get? This is 0.6565 volts we can get. This is gain in buck boost regulator. This one model of problem. This is the problem on practical condition. Okay. Try this. But one note you remember, sometimes the circuits may be represented like this. Okay, if any circuit is given like this, for example, this is inductor, and this is the switch representation, and this is the diode, and it is voltage is applied like this. This is V1 voltage and this is V2 voltage, and this is a regulator circuit as shown in figure, like that it is mentioned that. Then what is this regulator you identify? Yes, this is the boost regulator, because its inductor is at source side, then it is a boost regulator. The point to remember, it is a boost regulator. Instead of giving total circuit, if it is given like this, the formulas are same. Whatever the formulas I given for boost regulator, all are applicable this one. If you have any doubt, any doubt in the identifying of the circuit, simply you remember, if switch is grounded, it is a boost regulator. If switch is grounded, it is a boost regulator. If switch is grounded. If inductor is grounded, it is a buck boost regulator. If it is not these two, then your answer is buck regulator. Like that also you take. That is if switch grounded, based on this configuration, how to identify the regulator? It's a buck regulator or boost regulator or buck boost regulator, how to identify? If switch grounded, then you take this is boost regulator. If inductor is grounded, if L is grounded, then you take buck boost. Buck boost regulator. If these two are not, otherwise, if not, take buck regulator. Like that also you remember. In the total circuit, how to identify buck regulator and boost regulator, I told. Inductor is at load side, buck regulator. Inductor at source side, boost regulator. If the inductor is at middle, that is the buck boost regulator. If the total circuit is given. Sometimes if the total circuits are not given, then go for this identification. Switch is grounded, boost regulator. Inductor is grounded, buck boost regulator. If these two are not, then you go for the buck regulator. Understood? Okay, this about in detail about classroom workbook based on buck regulator and boost regulator and buck boost regulator. In the next session, we will continue with another concept in the chopper, that is in DC to DC converter. Another type of concept is what are the types of choppers based on quadrant operation. Still two topics are there. What are the types of choppers based on quadrant operation and types of choppers based on commutation circuit. That is a thyristor chopper. Okay. In the next session, we will continue with that next concept. With this classroom workbook is completed based on this concept.